Okay, so here's question number 10 for section 3. So they seem to really like the decomposition of calcium carbonate, it appears. But anyway, the question is just talking about calcium carbonate decomposing and turning into calcium oxide and carbon dioxide gas. So the first question is, what are the moles of CO2 produced? So again, you ignore this because what they're giving you is volume, temperature, and pressure. So you're going to be using PV equals nRT, and then you'll end up with that many moles of carbon dioxide. So even though you started with 50 grams of CaCO3, the result is 0.0115 moles based on the gas laws. So the next question, B, is the student claims that the final pressure became constant because all of the CaCO3 decomposed. That is not true. So if all of the CaCO3 decomposed, the system, number one, would not be in equilibrium. So it would be just completely turned into products. You would not see a double arrow. And then more detailed, if you started with 50 grams of calcium carbonate and you use stoichiometry, right, you convert it to moles, and then you convert it to the molar ratio in the balanced equation, you'll end up with that many moles. So in theory, if you started out with 50 grams of CaCO3 and in a perfect world it all decomposed, you would end up with that many moles. But based on the conditions that they gave you with volume and temperature, you only ended up with that many moles. So definitely not all of it decomposed. Same thing if you're looking at it from a 100 gram standpoint, then you would actually end up with one whole mole of carbon dioxide, and you got nowhere near that. So this is actually a really inefficient reaction. So what I wrote here is, according to the reaction stoichiometry, I'm just going to follow along here, 50 grams of calcium carbonate would produce that many moles of carbon dioxide, not that much. This reaction is quite inefficient. Again, I just put that in my own words to try to help you. In these conditions, since you're starting with 1 mole of calcium carbonate and you're only producing that much carbon dioxide. C is Le Chatelier's principle. So what the question says is that over time you added carbon dioxide gas. So this is confusing because you would think, of course, you're adding a gas, the pressure is going to go up, but an equilibrium system is weird. So when you add a stress, remember, if you're increasing a stress, say on this side, the system is going to shift away from that increase. So even though initially you're going to have a higher pressure, over time the pressure is going to equalize and you're going to get back to your normal equilibrium. And that is the case because it is a sealed system, and the only thing that's going to change the equilibrium, the Kp, is going to be temperature. So what I wrote here is initially the pressure would increase, but the stress of added CO2 would shift the system to favor the reactants or to the left and will not change Kp or the pressure. Okay, and then the last question on this one is D, and it says, is there sufficient data in the experiment to determine the value of the equilibrium constant? And this relates pretty closely to number 9. And sorry, I had to move over here in the margin. I said yes, because Kp is equal to the partial pressure of CO2. And we have the partial pressure of CO2, which is 1.04. The one thing I forgot on question number 9 is when you do a Kp expression, you really should put your partial pressure in parentheses. So I don't know if they would take off for that, but I think if a lot of students did really well, they would take off for things like that. So just be careful, make sure you have the parentheses around your partial pressure. Okay,